Question 2. We have a swinging door. It has an angular position that is described by the following equation. All right, there's a theta in here, and it's given by some equation with factors of t involved, variable on t. Find the following. Okay, if t is equal to 0, calculate the angular position, the angular velocity, and the angular acceleration. Okay, so for this, to calculate the angular position, that's the first one. All I have to do is throw in when t is equal to 0, because this is already a position equation. So I get 4.99 plus, this is going to go to 0, because if t is 0, this is going to go to 0 if t is 0. So my answer to that should be 4.99. Okay. Just for clarity, I'm going to go ahead and rewrite this down here. 4.99 plus 10.3t. You don't have to do this, but just so we're clear on where all the variables are coming from, I'm going to go ahead and rewrite it. That's for theta. That's fine. That's how we get the 4.99. For velocity, though, I need to turn this into the velocity equation. And we know then that velocity is just a derivative of position. So in our case, it'll be d theta dt, the derivative of the angle. So to get this, okay, to get w over here, we'll have to take a derivative of this with respect to time. So ddt of a constant just falls away. ddt of a constant is 0. Okay. ddt of something to the first power means that the t will drop. So this is just power rule. We would have, if you wanted to do power rule, we have 1 times 10.3 times t to the 0, which is 1. So 1 times 1 times 10.3 gives us 10.3. We'll do the power rule on this one as well. So that 2 will come down, and we'll have 2 times 2.08, so that will give us 4.16. And then we need to minus 1 from up top, so we'll have t to the first, but we normally don't write t to the first, we just leave it as t. Now, since we have an equation now for w, if we plug in t is equal to 0 for this equation, what do we get? Well, there's 0 in front, so that doesn't matter. There's no t, so we'll have 10.3. And then this t here goes to 0. So we'd have 0, 10.3, and 0. So that gives us 10.3. For the last one, the angular acceleration, we need an acceleration equation. Okay, and we know that acceleration is simply another derivative. Okay, so we'll take another derivative on w. Derivative of 0 is, of course, 0. Derivative of 10.3, it's a constant. It is 0. Derivative of 4.16t, same thing happened like it did here. The 4.16 will come down, and t no longer is in the equation. We just have 4.16. Now if I plug in t equal to anything in here, the acceleration is constant. It doesn't vary with time, so of course the acceleration will be 4.16. Part B to this says now figure that t is equal to 3.1. Calculate the angular position, velocity, and acceleration again. Okay, so all you have to do for these numbers is go ahead and plug in when t is equal to 3.1. So for this one, we would have 4.99 plus 10.3 times 3.1. Plus, we would have 2.08 times 3.1 squared. And if we do that out, we get 56.9088. So 56.9 will be just fine for our angular position on that. We do the same thing then for W. We'd have 10.3 plus 4.16 times 3.1. Okay, we put in 3.1 for t, and we get the exact same 23.196. We'll round that up, 23.2. And for the last one, there's no t value. So again, you can plug in t for whatever you want. There's no t to plug in, so our acceleration remains the same at 4.16. Now when you do this out and you get these answers, include the units, okay, so that we'd have 4.6 radians, 10.3 radians per second, 4.16 radians per second squared, so that you get used to putting the units on the back of these.